So let's go to example 1. Do you recognize the graph? They just tell us f of x, but do you recognize that that was one of our colored paper ones? This is the absolute value of x. So it says here's the graph of y equals f of x. Sketch the graph of y equals negative 1/4 f of x. So what we're going to start doing as we add more and more things to our graph is we are going to start labeling what we see. This is outside. I'm going to label that negative as a vertical reflection. V for vertical, R for reflection. And the 1/4 will be a vertical compression. What's going to happen is all of our original points algebraically, you're going to multiply your y values by, and you can do both the vertical reflection and vertical compression at the same time. All of our y values are going to get multiplied by negative 1/4. So what are some key points? We definitely need to do this one, 0, 0. And maybe I would choose either this point or this point. And I'm choosing those ones because they have nice y values of 4 and 8 that I know I can multiply by 1/4 easily. You're also going to see, as we get into more and more complicated ones, a method for showing the work. So a method that you could show the work is if I took these 5 points and I labeled them. This one would be negative 8, 8, negative 4, 4, 0, 0, 4, 4, and 8, 8. Those are the 5 points that I have listed there. And we're going to change them. So I draw an arrow to say these points are going to get changed. And the way that we're going to change them, because we wrote out above this arrow, I'm going to say what I'm going to do. I'm going to multiply my y values by negative 1/4. This is a way that I can do the mental math and show my work. Like, okay, my y/4, my y value was 8. So if I multiply that by negative 1/4, my x wouldn't change, but now I would get negative 2. And with negative 4, if I multiply that by negative 1/4, I get negative 1. 0, 0 wouldn't change. And this technique of drawing the arrows is going to be helpful, especially when we get to ones where we do 4 things. Like if we multiply y by something, multiply x by something, add something to x, add something to y, it could get complicated just to do it all at once on the graph. For this one, I think you probably could have done it, right? Could you imagine multiplying this by negative 1/4 and that point staying the same? Taking this point at 8, multiplying by negative 1/4 and getting negative 2. This one getting negative 1. But drawing it out and labeling the points afterwards is easy as well. We then draw our final graph. Now, this one in the textbook, they gave us the graph, but this question, because it was one of our colored questions, this could have come up as the following. I could give you the same question, much shorter, and just say, graph y equals negative 1/4 absolute value of x. And you would have to look at this and say, oh, I know what the absolute value of x is. I'll draw that red graph first on my paper. And I know how to label points on there because I have the shape memorized and I can easily find points. And then You would have to draw the blue one after. Question.
Would I need to write, make a red one? Or
You wouldn't have to make the red one, but often we'll just like have a sketch, or you need to say what, you have to know what the original points are. So drawing the red one just sort of references that you know what you're doing. And then there would be, technically there's no points given for drawing the red one, but it is sort of part of the work that you would show. Now it says state the domain and range of each function. So let's start with the red one. The original one's domain was everything, and the range, the y values are bigger than or equal to 0. Then on the blue one, the domain is still everything, but now our range, the y values are less than or equal to 0. Just circle question number 3.